Okay guys, so in this video, I'm just gonna quickly talk about one question and the first question in your book, and then we learn how to use these equations. Okay, so how do we actually apply them? Okay, so let's have a look over here. These are the equations given to me, so that will be gonna be in the equation sheet. But let's pretend I don't know which one timing starts from where. Okay, so we don't know which one to choose, and we look at the question and then see how we can figure this out. Okay, first it goes this. Okay, an object is vibrating vertically with a simple harmonic motion of amplitude at 24. Okay, so I'm gonna write amplitude at 24 centimeter. I'll make it to become 0.24 meter. Okay, and then you have the frequency, tells us frequency f equals to 5.0 per second. So that is same as hertz. Okay, calculate the angular frequency of the motion. That's easy. Without them saying anything, first thing I do is I always calculate the angular frequency. 2 pi f. Put that in my calculator. 2 times 3.14 and then times 5. Okay, 31.4 rad per second. Okay, all right, question A sorted, easy. Okay, question B, if the time starting at the top position, calculate the speed at the end. Okay, speed equal to this one or equal to this one. Okay, so let's have a think. Timing starts at top position. Top position. What is the speed at top position? At top position, the speed equal to 0, right? If the speed is 0, so that means timing starting when speed is 0. And then it's going to have a speed. So this is going to be a sine graph. So which one do we choose? We must choose this one, because this one is going to be a sine graph. That shows me timing, because sine graph starts from 0. We are starting from 0, the top position. Okay, so that equals to negative a omega sine omega t. Okay, and now I can put my information in there. So negative 0.24 times 31.4 sine 31.4 and times the time 0.13 seconds. Okay, and then I need to put it in the calculator. You see over here, I always make a bracket. It's because you are assigning the whole thing over here. So make sure you have a bracket here. Okay, in the equation sheet, they don't have bracket. Okay, so let me put this in the calculator then, and also make sure you're using radian over here. So I'm gonna go 0.24 times 31.4 times sine bracket 31.4 times 0.13 bracket. Okay, it equals to a negative 6.1 meter per second. Okay, if it's a negative 6.1, it means it's going downwards, right? Okay, going downwards, yeah. Okay, so question C. If the timing starts at equilibrium position, calculate the size of acceleration 0.13 seconds after timing starts. Okay, so timing now starts at equilibrium. So T equilibrium, T equal equilibrium. Okay, we're talking about acceleration. Acceleration at 0. Equilibrium, there's no acceleration. So when timing is 0, acceleration actually equal to 0. 0. So this is going to be a sine graph as well. I don't know if it's sine up or sine down. Let's have a look. Well, we need to be a sine graph, so it must be this one. Okay. So because this is a cosine graph. Okay. A equal to negative omega squared, a omega squared sine omega t. Okay. Let's put the numbers in. Negative 0.24 times 31.4 bracket squared times sine bracket 31.4 times 0.13 seconds. Okay, so again, I'm just gonna put that in my calculator to calculate. So 0.24 times 31.4 times 31.4 times sine 31.4 times 0.13 bracket. Okay, the acceleration I gave, oh, that's a really big number. 191 meter per second squared. Okay, it is a quite big number. 31.4 divided by f, frequency is 5. Yeah, okay, that is a very big number, so it's a big acceleration. Page 248, let me have a quick look at the answer, 248. Yeah, it is 191. Yeah, okay, all good. Yeah, okay. Cool. And then next question, question 3. So from these two questions, you can see how do I pick those equations, right? Okay, so all you can just remember, this is timing start from equilibrium, this is timing start from end position, okay? Or if you don't remember, you just use this, okay? And then question D, let's have a look. Calculate the maximum speed. Oh yeah, so this is the one I talked about. Maximum speed, we ignore everything else because this is going to be the maximum speed. Maximum just equals to A omega. Put in the calculator, 0.24 times 31.4. 7.5 meter per second. Okay, question E. Calculate the size of acceleration of the object when its displacement from the equilibrium position is 15 centimeter. Okay, so now we want to know acceleration. We can use this equation, give us displacement. So A equals to a negative omega squared y. So acceleration equal to negative, that's 31.4 squared, and times displacement, which is 0.15. And this one did not tell me if it's going upward or downward, so you can just ignore the positive or negative sign, okay? It doesn't matter how big you get. So the acceleration I have is 30.1.4 times 31.4 times 0.15, 148 meter per second squared. Okay, so F, last one. Okay, calculate the time it takes for the object to increase its speed from 0 to half its maximum speed. Half of its maximum speed. We've calculated the maximum speed over here. We say, well, that speed we want is half of the maximum speed. So half times 7.5. Okay, that gives me 3.75 meter per second. I want to know the time takes for it to go from increase speed from 0. Speed starting from 0. Again, that's a sine graph, so it should be this one. This is speed starting from 0. Okay, so V equal to negative A omega sine omega t, right? Okay, and then the speed over here is 3.75. And because the speed is going to starting with a negative speed. Okay, so that's because sine is going to go up. Because this is a negative sign, so it's going downward. So we can just ignore that negative because a negative 3.75 is going to be a 3.75 as well speed. Okay, so it's very important for us to ignore this. Okay, and then that will equal to, we just make it all positive. So 0.24 times 31.4 times sine 31.4 t. Okay. Okay, I just quickly explain why we use 3.75 instead of negative. Why do we get rid of the negative sign? Okay, so it's because of this. Say this graph over here. I'll draw it on the top. So this graph over here is gonna, because it's a negative sign, it's gonna look like this shape. Okay, so speed and time. So when you calculate, you want to know the time taken for it to reach. So the maximum speed is going to be 7.5, and this is going to be negative 7.5. You want to reach maximum speed, you only need to reach over here. Okay? If you use a positive 3.75, you will be calculating the time when it's reaching over here. And you don't want to calculate a positive time reaching over here. You just need to have this negative 3.75 over here. That is already half of the maximum speed. So that's why you had a negative over here, and then that will be a negative over here. These two negatives can cancel out each other. So this to make sure that you're not calculating this time, you're not calculating this time, you're only calculating this little bit over here. Okay, all right, and now you can put that into the calculator. Say sine 31.4 t equals to 0.497. So continue right over here. 31.4t equals to sine negative 1, 0.497. Okay, 31.4t equals to 0.52. T equals to 0.52 divided by 31.4. 0.0166 seconds. Okay, so that will be the answer for this whole question. So yeah, have a try with the questions, and then all the answers are on the back, and then see if that all makes sense. Okay, yeah, I'll see you guys in the next video.